Hello, hello.
For a diesel engines. So here you see the diagrams of an individual pump and injector system. So from the name you can understand that if it is a four cylinder engine, then different four pump and four injector systems are used. So here you see this is the four injection nozzle is available, means this is the diagram for a
Hello, hello.
GoDaddy offers hosting that's reliable and simple to set up. Get 99.9% uptime and best in class security to keep your online business running.
Hi friends, today we'll be dealing with the working of a fuel injection pump. Actually, the fuel injection pump is the heart
साउंड नहीं आ रहा है।
As per the requirement, the fuel injection pump will sense the movement of this metering valve, and the fuel from this vane pump or this rotor will be collected and supplied towards each injectors as per the demand. But it is happening only by the functioning of this fuel injection pump. Yeah, the fuel injection pump senses how much fuel need to be sent according to the demand of the metering valve position. So this is how if the fuel is carried from the fuel tank collected by the rotor, and finally it reaches the injectors. So I think you understand the function of a fuel injection pump. Thank you.
Hello. Hello.
ਅੱਜ ਮੇਰੇ ਨਾਲ ਇੱਕ ਐਸੀ ਸ਼ਖਸੀਅਤ
हेलो, कोई है मीटिंग में? हेलो, राहुल कुमार यादव। हेलो। 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 हेलो राहुल। हेलो। हेलो। Let us see videos of common rail diesel injection system.
Hey guys, welcome back to the channel. The Hyundai Accent Elantra i10.
Fuel at lower pressure makes the fuel less atomized. This could result in more mixing of air and fuel, leading to balance.
So now there's a little bit of understanding about CRDI system, Common Rail Direct Injection System for diesel engines. Now,
ये देख सकते हैं यहाँ पे नॉर्मल हुआ है।
now we are going to watch a distributor type of fuel system.
And the fuel is distributed to each cylinder by means of a rotor. The distributor type fuel injection pump has a single pumping element, and the fuel is distributed to each cylinder by means of a rotor. It is small in size and lightweight.
Hello, hello, Ranjit Kumar. Hello,
Yes, sir. Yes, sir. Yes, sir.
the screen share हो रहा है? Distributor type fuel pump.
अभी नहीं हो रहा सर, पहले हो रहा था, अभी नहीं है।
अच्छा, अभी देखिए तो स्क्रीन शेयर हो रहा है कि नहीं?
हो रहा है सर,
यस सर, स्क्रीन आ रहा अभी।
आ रहा सर, आ रहा।
चलो अभी स्क्रीन शेयर हो रहा है क्या?
यस सर।
Yes, sir.
अरे वो डिस्ट्रीब्यूटेड टाइप फ्यूल पंप कहाँ गया? अच्छा, एक तो इंजन लुब्रिकेशन के बारे में वीडियो
सर
है।
ये वाला हम लोग को शेयर किए डॉक्यूमेंट,
नहीं, हम शेयर नहीं किया है।
इसको कर दीजिएगा सर।
क्या लिंक चाहिए आपको? कौन सा लिंक चाहिए बोलिए तो?
इसमें तो स्टार्टिंग से सारा लिंक दिया हुआ है ना हर चीज का, इसलिए हम बोल रहे थे ये शेयर पूरा कर दीजिए, ठीक रहेगा। इसमें तो
स्क्रीन शेयर में प्रॉपर जगह में जा नहीं पा रहे हैं। हेलो, स्क्रीन शेयरिंग हो रहा है? हेलो
यस
हेलो।
सर।
Can see this movement over here and also the rotation of the rotor. It's a vane type pump over there. So these are the internal components. This is the top view, which consists of the throttle lever. And this is the internal side view, and this is right side view. So let's see how it works in detail. Okay, so these are the views as I told, the top view of the fuel injection pump, the front view with an internal view, and this is the side view. Okay, now let's see in detail. This is the rotor pump over here. This is a vane type pump, and you can see these are the four vanes which are marked in red over here, and in between them there are springs. These vanes have been connected using springs. You can see this is the casing of the rotor pump, and it is connected towards these vanes are connected towards this particular circular object, which is a bit offset from the axis, the center of the axis of rotation of the casing. So as you can see, when the rotor pump rotates, these vanes adjust automatically when it rotates because of the spring at center. It adjusts the movement, right? And those are the injector lines. This is the head of the pump. So from these injector lines, the connection is going towards the fuel injectors, and that's the fuel in. The fuel is supplied from the fuel tank into the FIP, or the fuel injection pump, through that line. That's the head of the fuel injection pump. That's the rotor. You can see this is a side view which showing the rotor, and this is internally how it comes inside the head. Okay, and that's the metering valve. The metering valve is actually connected internally through a gallery towards the rotor. The movement of this metering valve adjusts or controls the fuel supply. That's the governor weight retainer. It actually looks like a flower. Inside it have 4 or 5 weight retainers inside that. So as it moves, this flower closes up and opens up depending on the RPM and the demand, and which push this particular blue line over here, which I'll be showing in the animation coming. So that's the plunger. This plunger is connected towards our rotor, which is connected by the drive shaft, which gets its drive from the engine, resulting in the rotor to rotate. Okay, that's the drive shaft, and it gets its drive from the engine. It is connected towards the engine side. So this is getting mounted towards the engine to get the drive for the fuel injection pump. And those are the governor arms. So as this metering valve and the governor arms move simultaneously, same way as the governor retainers move with the RPM of the fuel injection pump. So that's a throttle shaft, and that's connected actually towards the accelerator pedal through an accelerator cable. So when we push the accelerator pedal or when we release the accelerator pedal, this accelerator cable actually controls the movement of the throttle valve, which gives a demand towards the fuel injection pump for creating the fuel flow. So let's see. So the drive shaft rotates. How it works? The fuel injection pump working has been explained now. The drive shaft rotates. You can see it result in the movement of the governor weight retainers. You can see the governor weight retainers are also rotating right now. You can also see the vane pump or the rotor pump is also rotating. So when the governor weight retainers rotate, that gets its drive through the drive shaft from the engine. So when the RPM increases, what happens is that slowly these governor retainers will result to move frontwards or backwards. So it is depending upon the RPM of the engine that actually creates the fuel demand. So at more RPM we need more fuel. So you can see this metering valve is also rotating, and also this particular lever, which is in blue, is also moving because this governor weight retainer is pushing it, and it is connected through this ash colored spring towards the metering valve. And metering valve has an internal gallery connected towards this green one is internal gallery, which is connected towards our rotor pump or the vane pump. So this yellow is showing the internal view of the vane pump, which is over here. So the vane pump is actually supplying the fuel as it rotates. So the drive reaches the vane pump, and the vane pump rotates and supply the fuel through this gallery, through the metering valve, and that connection is going towards the injector lines. So as this moves like this, the metering valve moves, and that gallery actually is being controlled by the demand of the RPM. So that's one thing that's controlling the demand of the fuel flow towards the injectors. And also, when the driver is controlling the accelerator pedal, the cable connected towards this throttle valve also can be moved. So when this throttle shaft, or I mean this throttle connection, which is connected towards the accelerator pedal moves, it actually moves the metering valve because it is directly linked towards this governor arm. Just have a look at that. You can see clearly over here when this throttle lever moves, the governor arm moves, and resultingly the metering valve also moves. So that metering valve movement controls the fuel supply or the gallery, and that much amount of fuel only will be supplied towards the fuel injector line. So these are the two factors which are helping the fuel flow in a fuel injectors. It gets its drive from the drive shaft, result in the vane pump to rotate, and the governor retainers move frontwards and backwards automatically according to the RPM of the engine, resulting in the governor arm to move, which is thereby controlled the metering valve and the galleries, which supplies the oil towards the injectors. That's automatically how the fuel demand is being sensed. And when manually the accelerator is being pushed, again the governor arm is controlled and the metering valve is being controlled by the driver. That demand is also taking care of this gallery, which supplies the fuel through the injectors. So that's simply how a fuel injection pump works internally. So I believe you understand how a fuel injection pump works internally. Thanks for watching this video. Have a great learning experience.
हेलो, कोई है मीटिंग में? हेलो हेलो, राहुल कुमार यादव. अभी
four-cylinder engines. So here one cylinder, here second, third and four cylinders. In this injection nozzle,
हेलो, ये स्क्रीन शेयर हो रहा है? हेलो,
यस सर.
so from the name you can understand that if it is a four-cylinder engine, then different four pump and four injector systems are used. So here you see this is the four injection nozzle is available, means this is the diagram for a.
Hi everyone, welcome back. So in today's lecture we'll be discussing about air injection system and individual pump type fuel injection system. So I already discussed, if this is an engine cylinder, then basically in most of the designs
सर साउंड नहीं आ रहा.
to reduce
देखो, अभी आ
emission
रहा है कि
gases will improve fuel economy, power output. This system is called as, this complete system is called as injection system, or rather fuel injection system. So before moving towards air injection system, CRDI, common rail diesel injection system, individual pump distribution.
Hello.
So you should know that different types or categories by using this fuel injection systems can be classified. So the first is, when many years before, when the fuel injection system is developed, which is developed by Rudolf Diesel. So first system which is used in an engine is air injection systems. So in air injection system, basically fuel and air will be combined, mixed with each other, and with the help of this complete system, maybe with the help of this pump, this fuel and air mixture, with the help of this pump and compressor, this fuel and air mixture will be combined, and the combined mixture will be supplied to the engine cylinder. So air is also there, which is supplied along with the fuel, and the name air injection. We compress, we use air in the compressor. We know that we'll be having inlet valve and exhaust valve. In diesel engine, we know that through inlet valve, the air will come inside, which is compressed in the compression stroke, and at the end of compression stroke, fuel air mixture. We have seen the fuel air mixture will be only supplied in case of SI engine, but here in previous engines, this air injection system nowadays we do not use in any vehicle, but when it was developed, this has been successfully used in many vehicles. So in that case also we will supply the fuel and air mixture through this nozzle, high pressurized fuel and air mixture, and air is also compressed. So air is supplied through this fuel injector also, and air is supplied through this inlet manifold also. But then the researchers coming across many difficulties or even the effect of on efficiency, power outputs. So there are many disadvantages were there as far as air injection systems was used, and that is the reason solid or airless injection system is developed. Obviously, as the name itself implies, it is a solid system or airless system, means air is not utilized. Nowadays, in almost all the vehicles, we utilize solid or air injection systems. So that does mean through this fuel injector, will only inject fuel, and the name as solid or airless injection system. And in solid and airless injection system, you will find number of types or number of subtypes. So I will categorize this solid or airless injection system into two main categories: mechanical and electronic injection. In mechanical injection, we have heard this name few years before this system is invented, common rail diesel injection system. This can also be called as CRDI. We know that even on some vehicles itself it is displayed about CRDI. Then individual pump, and then distributor type. So in today's lecture, we'll be discussing about this air injection system in details, and then we'll move toward this individual pump type fuel injection system, and probably in next video we'll be talking about this common rail diesel injection system and this distributor type diesel injection system. So let's discuss about construction details and working of air injection system first. So it is developed by Rudolf Diesel, and nowadays you will not find in any application, you will not find the use of air injection system, but as this is the first system developed, so you should know how this system has worked. So first important part is obviously engine. So this is a fuel injector. We'll be having this inlet valve and exhaust valve. So we have discussed the pressure of this fuel injection is minimum 70 bar or even more than that. So now I have to supply, we know that in air injection system we supply fuel plus air mixture, diesel plus air mixture. So in order to supply this high pressurized fuel and air,
to P2, this is to P3, this pump to P4. And this pump